Hello everybody. Welcome to the fresh session today. We had a break yesterday. So today we'll be discussing a topic from mathematics, basically coordinate geometry. Uh, uh, just give me a minute. Yeah. So here we are. We'll be discussing a chapter from coordinate geometry called hyperbola. And as you already know, these sessions are not for discussing the entire chapter. We'll be discussing a small topic from or a subtopic from this topic called parabola, which is known as the tangent to a hyperbola. So personally, giving you short tips about this examination, what I would like to tell you is there are two topics in mathematics which are extremely scoring. One of them is vectors. Once you initially, like, because you've never visualized vectors before, when you study vectors for the first time, it feels really complicated. But when you actually understand vectors, you will realize that the number of questions that can be framed as far as vectors are concerned are very minimal. Like, they can't really go into the depth of the concept because the concept is not that deep. So you can actually score as far as questions from vectors are concerned. And a similar argument goes with coordinate geometry. Coordinate geometry is a deep topic. I'm not saying it's not deep, but what comes in your examination is not at all deep. Like, it's pretty simple to score from these chapters. So whenever you get anything from coordinate geometry, basically conic sections, it's also called conic sections, make sure you are thorough with these topics so that you don't miss out on the questions from these topics. They are extremely scoring, both mains, advanced, and obviously bitsat as well. So let's move ahead to discussing what this concept is. So we'll take the standard equation of a hyperbola, which you already know is x square by a square minus y square by b square is equals to 1. Right. So when you draw this hyperbola, you already know it looks something like this. If I take a point x1, y1 on this parabola, and if I want the tangent at this point, so tangent is a straight line which actually passes through this point. If I want the equation of this tangent, let's see what is supposed to be done. Right? It's a pretty simple application of derivatives which we'll apply here, and then we'll actually figure out what the equation for the standard equation for a line to be a tangent to a hyperbola is. So just differentiate this equation. So you have 2x by a square. I would write it like this, dx by dx, like differentiate with respect to x, which will actually turn out to be 1, minus 2y by b square into dy by dx. There are two variables, x and y. I'm differentiating both with respect to x, so that's why dx by dx will obviously turn out to be 1. So you have this equal to 0. So what you have now is 2x by a square, 2x by a square is equals to 2y by b square dy by dx. So extracting dy by dx from this equation, what we have is b square by a square into x by y. Right, this is what we have. So this is the general equation for slope. Like, this dy by dx is the slope of this line, right? You can actually say tan, if this is theta, dy by dx is basically tan theta, right? Or it is the m of the line. So m of the line, I want it at x1 y1, right? I just don't want a general one. I want the equation of the tangent at x1 y1. So like I'll put x1 y1 here. So what I'll get is b square by a square into x1 by y1. Right. So let us try to simplify this now. So you want the equation of a straight line. You want the equation of a straight line whose slope is already given. Not given, you have actually calculated. And the point, you also know a point on the line which is x1 y1 itself. So once you have a slope and a point, you can use the slope point form to get the equation of the line, which is y minus y1 is equals to m, which is this b square by a square into x1 by y1 into x minus x1. Right? So this is what you have. Let us try simplifying this. So this, what is this? This is the equation of this tangent, right? Let's try simplifying this. So taking this a square y1 this side, what we have is a square y1 minus a square y1 square is equals to b square x1 minus b square x1 square. Trying to simplify this further. We'll divide on both sides with a square b square. So we'll divide on both sides with a square b square. So what you now have is this a square gets cancelled with this. So you have y1 by b square minus y1 square by a square. Sorry, y1 square by y1 square by b square is equals to x1 by a square minus x1 square by a square. Rearranging this equation, what we now have is getting this x1 by a square that side, this y1 by b square that side, and x1 by a square on the right hand side. Sorry, x1 square by a square on the right hand side. Let us try simplifying it further. Now you'll try to understand why is it that we are trying to arrange it like this. It will give rise to a simple notation. So what we have is x1 square by a square minus y1 square by b square is equals to x1 by a square minus y1 by b square. So as you already know, x1 y1 lies on this line, lies on the hyperbola and also on the tangent. So because x1 y1 lies on the hyperbola, I can put x1 square, like I can put x1 y1 in this equation, and what I'll get is x1 square by a square minus y1 square by b square is equals to 1. Why? Because x1 y1 lies on the parabola. So like this is equal to 1. So like this x1 square by a square minus y1 square by b square has to be 1. So I'll replace this thing with 1. And now finally rewriting this equation, what we have is x1 by a square minus y1 by b square is equals to 1. This is the equation of the tangent to the hyperbola at x1 y1. I can simplify this and I can write it in a short notation called s1 is equal to 0. What does s1 mean? So s1 means this: x1 square by a square minus x square by a square minus y square by b square is equal to 1. Let this be s is equal to 0. Then x1 by a square. So if you see, I'm taking out one x. This x square I'm writing as x into x, and y square I'm writing as y into y. And one of the x's I'm making x1, one of the y's I'm making y1. So then I'll get this. This is called S1 is equal to 0 for the curve S is equal to 0. And S1 is equal to 0 is the tangent to the curve if the point lies on the curve. S1 is equal to 0 will give the tangent to the curve, right? This is something that you have to understand, something that you have to remember actually. So I can also write the tangent in this form. So there are three forms of tangents that are necessary for you to remember. The first form was this. The same tangent, basically, I'm having the same diagram, x1, y1. Remember, x1, y1 can also be written as a secant theta, comma b tan theta. The general point on a hyperbola, the same point, x1, y1, it's a general point, right? In terms of theta, I can write this general point as a secant theta, comma b tan theta. So that's why you'll have one form of tangent as this. This is basically S1 is equal to 0 if x1, y1 is given. The second one is not at all different. If I want to write the equation of the tangent in terms of theta, if my point is given in terms of theta, then x1 I can replace with a secant theta minus y by b square, and y1 I can replace with b tan theta, and this will be equal to 1, right? So what I have is x secant theta by a minus y tan theta by b is equals to 1. This is the second form for the tangent to the same hyperbola. Let's move on to discussing the third type. So I have the same curve here, x1 square by a square minus y1 square by b square is equals to 1. The third form is the line y is equals to mx plus c. So it was a straight line, right? We already know what m is for that line because you can calculate it by differentiating, basically. So you have y is equals to mx plus c here given. When is this line a tangent to the curve? That is what you have to understand. So what I'll do is I'll substitute y in this equation. So I have x square by a square minus mx plus c whole square by b square is equals to 1. So I have b square x square minus a square m square x square minus 2mcx a square minus a square c square is equals to a square b square. So what did I do? I just cross multiplied a square b square, and then finally I took a square b square that side. It's nothing complicated, pretty simple. So this is what we have, 2mcx into a square, yeah, minus a square c square. So collecting the coefficients of a square, x square first, I have b square minus a square m square. Collecting the coefficients of x, I have x into minus 2mc a square, and then finally the constants, and that is minus a square into b square plus c square is equal to 0. This is, what is this basically? I'm trying to calculate the x coordinate for the point to which this is the tangent, right? Because this is I've taken the straight line, put in y, got the equation only in terms of x. What is this x going to give me? It is going to give me the point where this straight line intersects this curve, right? And because I want this straight line to be a tangent, that means this straight line should intersect this curve only at one point. Only at one point. That means this quadratic equation should have repeated roots, right? It should not have a different x1 and x2. Otherwise, that would mean that the straight line is intersecting this curve at two different points, right? It has to intersect this curve only at one point. If it has to intersect only at one point, that would mean, so if I have a quadratic like this, ax square plus bx plus c is equal to 0. Similar to this, If I have a quadratic, if I want the quadratic to have just one root or basically repeated roots, then its discriminant should be 0, right? So b square minus 4ac should be 0. So I'll apply the same thing here. This is my a now, this is my b, and this entire constant is my c. If I plug in the values here and I equate this expression to 0, what I'll get is, I'll straight away write the answer. So like, I hope you understood the procedure. So you'll have y is equals to mx plus c, where your c will come out to be, when you place it in, plus or minus under root a square m square minus b square. So if you have a straight line like this, such that your c is this, only then this straight line will be a tangent to this curve. That is what you have to understand. So the third form of tangent is this: y is equals to mx plus or minus under root a square m square minus b square. This is the third form of the tangent. So we have understood all the three forms. Hopefully, we can now move on to discussing problems. So for all real values of m, the straight line, this y is equals to mx plus under root. So what do you mean by plus or minus? Like, this is something slightly confusing, but it's actually not, because this is a tangent, and for the similar basically what this means is, we'll actually understand what this plus or minus means. It means that you have two straight lines which are differing just by a constant. That means, so the slope for both the straight lines are same, only the constant is differing, right? That means you can have two tangents drawn to the parabola at a given x coordinate. So this is your x coordinate here. For a similar x coordinate below, or you can have parallel tangents. We'll actually understand the application of this, right? So let's not go deep into understanding this right now. Let's discuss problems and then we'll realize what that means. So for all real values of m, the straight line this is a tangent to the following. Which of the following hyperbolas is what is being asked, right? We have four hyperbolas given. You have to find out for which of these hyperbolas is this a tangent, or is it for more than one also? Like, it can be. So we don't know. What we'll do is, so first of all, the question says which of the following certain hyperbolas. Then that would mean that these two options, because the question is about hyperbolas, option A and option B are straight away omitted. Why? You should be smart enough to omit such options because you have a plus in the middle. The plus would mean that these two are ellipses, like they are not hyperbolas at all. So I don't even need to check for them, right? C and D is what I have to check for because these are possible hyperbolas. So x square by, if I divide both sides with 36, I'll have to reduce it to this x square by a square minus y square by b square equal to 1 form. So x square by 4 minus y square by 9 is equals to 1. This is your C part, and your D part is x square by 9 minus y square by 4 is equal to 1. So a straight line is a tangent to the parabola if y is equals to mx plus or minus under root a square m square minus b square, right? So against m square, like the coefficient of m square should be a square, right? A square is what comes below x square. So here you have a 9, here you have a 4. In the given question, you are having a 9. that means it's corresponding to this parabola, right? 9 square m square minus 4. Sorry, 9, not 9 square m square, 9m square, because this itself is a square, a is 3, right? So it was a pretty simple formula, right? Just you should just know what this equation is. This was basically the third form of hyperbola. Sorry, the tangent to the hyperbola. Just have to analyze the equation and solve it. So let's move on to the next problem. Now you have to find out a value of m for which this equation is a tangent to the hyperbola. Let's see how we can do this problem. So you have x square by 100 minus y square by 49 is equals to 1. Straight line that you have is y is equals to mx plus 6, right? Well, I would say there are two ways of doing this problem. First, I'll tell you the the lengthy method, and the second is avoiding all of those steps and just analyzing the equation that we have actually derived. So first is you put this y is equals to mx plus c in this equation. Right. Collect coefficients of x square, coefficients of x, and your constant. Form a quadratic. So let the coefficient of x square be a, that you get by rearranging this equation. Let the coefficient of x be b, right? And let your constant that you get be c. Then what you have to make sure is, because this straight line is intersecting this curve only at one point, then that would mean that this quadratic is supposed to have just one root. That means its b square minus 4ac should be 0. Right, b square minus 4ac has to be 0. So you do that and find out the answer. I'm not doing it right now because we would actually approach to the smarter method. And in fact, we've got that formula by following this procedure itself. Like while deriving the equation for the third form, this is what I did. I put the equation of the straight line, like I put the straight line in the curve, got a quadratic in terms of x, and equated its discriminant to 0. Right, and that's how I got what I'm going to describe you now. So remember, for a straight line to be a tangent, it should have this form: y is equals to mx plus or minus under root a square m square minus b square. So you are having a plus here, so forget about this minus now. This is your tangent. So like your 6 should be this, right? So 36 should be a square m square minus b square. You have a square with you, which is 100. And you also have b square with you, which is 49. So you have 100 m square is equals to 85. Right. So m square is nothing but 85 by 100. So you can say that m for the straight line to be a hyperbola is plus or minus under root 85 by 10. Right, I hope this was not a difficult problem at all. So if you follow the previous method and you don't remember the equation of a tangent to a hyperbola, then in the examination you'll have to follow that lengthy procedure. You won't be able to get the answer quickly, right? And these are the kind of problems that commonly come in examinations. So if you remember the straight line, the condition for a straight line to be a tangent to the hyperbola, you would actually do this in just one step, right? Just analyzing the equation and getting the value for m. So this is why I wanted you to memorize that. So let's move on to the next problem now. Find the equations of the tangent to the curve which are parallel to the straight line. Right. Once again, there are if you know the equation of the tangent to the hyperbola, or a condition for a straight line to be a tangent to the hyperbola, it gets very simple. Otherwise as well, it's not at all difficult. So yeah, the straight line that you have is y is equals to 5 by 4x plus 7 by 4. What you want is, so there is a hyperbola 4x square. You have a hyperbola. You have a straight line which is this. So let this be a straight line. You want an equation to a straight line which is tangent to the hyperbola and also parallel to the straight line. So I will first, we'll actually first, or I would straight away tell you the best method to do this problem. So what you do is, because these two straight lines have the same slope and differ only by a constant, what we'll do is, we'll let the equation y is equals to, let this be a tangent to your given hyperbola, right? In fact, I need to rewrite the hyperbola as well, and I'll do that in this manner. So you have x square divided by 1 by 4 minus y square divided by 1 by 9 is equals to 1. This is your hyperbola. Let this equation, let this straight line, which is obviously parallel to this, be a tangent to this. If it has to be a tangent, what should C be? C has to be under root a square m square minus b square. It has to happen, otherwise the straight line is not a tangent at all. So what is your a square? 1 by 4. What is your m square? M is 5 by 4, right? So obviously your m square is 25 by 16 minus 1 by 9 is what you have. So simplifying this, we have 25 by 64 minus 1 by 9. So this is C is equals to under root 25 into 9, which is 225 minus 64 divided by 64 into 9. So I have C as, so 225 minus 64 is obviously under root, so subtract 264 from, you have 161, right? Divided by under root 64 into 9 is 8 into 3. So this means your C has to be this, under root 161 by 24. So these are, so you, because of this plus and minus, that's why the question says equations of tangents, because you have two tangents here, right, which are parallel to the straight line and obviously tangent to the hyperbola, right? So because you remembered the form, you could do this quickly. Otherwise what you would have to do is assume y is equals to 5 by 4x plus c to be a tangent, then put this in this equation, get a quadratic in terms of x and equate its discriminant to 0 to get the value for c, which you would actually get as the same as this with the plus and minus obviously. So I hope you understood the procedure for like the importance of memorizing this equation and what do you say, simplifying the problem from the exam's point of view, right? Let's move on to the next problem. So now you have to find the point on the hyperbola where this straight line touches it, right? So the hyperbola that you have is x square minus 9y square is equals to 9. So you have x square by 9 minus y square by 1 is equals to 1. So in fact, I'll write it in this form only. X square by 9 minus y square by 1 is equal to 1, the hyperbola. This is the hyperbola that's given to you. 5x plus 12y is equals to 9 is the straight line that's obviously given to you. So it's already given in the question that the straight line touches this hyperbola. In fact, you can verify that yourself as well. Like you can write 12y is equals to minus 5x plus 9, y is equals to minus 5 by 12x plus 9 by 12, or which is 3 by 4. So you have to just verify if this c square is equals to a square m square minus b square or not. So the c square is 9 by 16, a square is this, a square is 9, m square is 25 by 144, minus your b square is obviously 1, so this is 16. 25 minus 16 is 9 by 16, this is 9 by 16, so obviously they are equal, right? You're getting 9 by 16 equal to 9 by 16, that means whatever is given in the question is not wrong. This straight line is indeed a tangent to this curve. So once it's a tangent, it's a very simple process. What you can simply do here is like get the y from this and put it here. So x square by 9 minus 1 is equals to y square is what you have. So y square is again 9 minus 5x by 12 whole square. From this I'll get y from this, right? So 9 minus 5x by 12 square. So you have x square. Collecting the coefficients of x square into 1 by 9 minus 25 by 144 plus x times 45 by 6 into x. So I'm just simplifying it like just mathematics from here. So 45 by 6 is what you have, it will go there, it will become plus 45 by 6, and then what you have is minus of 1 plus 3 by 4 whole square, which is 9 by 16. So it's just mathematics. Once again I'm repeating, it's nothing complicated. So simplifying this, obviously what you have is yeah, the equation seems to be right. So I can straight away get the x coordinate by applying this formula. If this is your quadratic with repeated roots, then I can x is straight away minus b by 2a. Right? Because the discriminant part becomes 0. That's why straight away x is minus b by 2a. So here, because I know for this equation also I have repeated roots, so I can straight away get the minus b for this. So x is straight away minus b, which is minus 45 by 6 divided by 2a. So what is a here? A is again 16 minus 25, which is minus 9 divided by 144. So this 12 cancels this to be 12. So what I have is you have this minus cancels this to become plus. You straight away have x equals to 45 into 12 by 6 into, or just 9 basically. 45 by 12 cancels this with 12, 12 goes up, and then you have a 9 here. So this is obviously 9 5s are 45, so you have the x coordinate that you have is 60. You can straight away put this x coordinate in this and get the y coordinate in the line basically. So 16 to 5 is 300 plus 12y is equals to 9. So what you have is 12y is equals to 9 minus 300, which is minus 291, right? So y is equals to minus 291 divided by 12. So 3 can obviously cancel this. So you have 3 9s are 27, 3 7s are 21, divided by 3 4s are. So you have minus 97 by 4 here as your y coordinate. So this is the procedure that you follow to get the coordinates. Just check the calculations yourself once, because I have less space to write here. So in the process of erasing, if I just miss the number by just one sign also, I get the answer to be wrong. So it might also happen that I get the answer to be wrong, but the procedure is obviously quite clear to you, right? What you have to do. So once you have a pen and a paper and a lot of space to write, do this problem yourself and verify the answer. Even if it's wrong, the procedure is still the same. So moving on to the next problem, I need to find the equation of the tangent to this conic at this point. Now frankly speaking, verifying whether this conic is a hyperbola or a parabola or an ellipse is something that for which you'll have to memorize a few conditions. I wouldn't even actually ask you to memorize those conditions for such questions, or specifically for this question, because it's pretty simple. If this is your conic, s is equal to 0, then s1 equal to 0 at x1 y1 has to be a tangent to this conic if your x1 y1 lies on s is equal to 0. I hope you are understanding. You have this point x1 y1 which lies on s is equal to 0. If that happens, then s1 is equal to 0 at x1 y1 has to be a tangent. I don't even need to think about anything else. So we'll straight away do that here. So this is my first, I'll get my curve, that's x square minus y square minus 8x plus 2y plus 11 is equals to 0. First I'll get s1 for this. So what I have is x1 minus y1 minus 4 into x plus x1. So this is slightly tricky here. So once you have minus 8x, what you do is you take a minus 4 into 2x, basically minus 4 into x plus x, and one of these x's you make it x1. So that's how you get it, minus 4 into x plus x1. I hope you understood. It's just a notation, nothing else. S1 equal to 0 is just a notation of writing s is equal to 0 in this form. So for y, what you'll do is you'll take this 2y, you'll write this 2y as y plus y, and one of the y's you'll make y1. So it's y plus y1 plus 11 is equal to 0. Pretty simple. Now your x1 is this, y1 is this, and this obviously lies on this curve. You can put 2, 1 in this curve and verify. You'll get a 0, and that is why if I do s1 is equal to 0 at 2, 1, I'll get a tangent at 2, 1, right? If this 2, 1 doesn't lie on this, s1 is equal to 0 at 2, 1 will not give me an equation to a tangent, right? It has to lie on the curve. So x1 is 2, so I have 2x minus y minus 4 into x plus 2 plus y plus 1 plus 11 is equal to 0. So simplifying this further, 2x minus 4x is minus 2x, and the y's just cancel off, right? And then you have a minus 8 plus 12, 2x, y's cancel. Oh, this was an equal to, right? It's not a minus, okay, it's a minus 2x because you have a 2x minus 4x. Minus 8 plus 12 is equals to 0. This is what you have finally. So I can say that, okay, 2x is 12 minus 8, which is 4. So x is equal to 2 is the line. So this is the tangent to this. So basically must be a hyperbola. I can't draw this hyperbola right now straight away. It's not that easy because it's not in its standard form. But what I know is the tangent to this hyperbola is this line x equal to 2. This line will touch this hyperbola at 2, 1. Right. This is something that I can guarantee. Moving on to the next problem. Find the equations of the tangents to the hyperbola that are drawn from 3, 2. So this is slightly tricky. This 3, 2 doesn't lie on this curve. So if you do S1 equal to 0 at 3, 2, will you get a tangent to the curve? No. Because 3, 2 does not lie on the curve. So I'll not get a tangent if I do S1 equal to 0. But yeah, obviously there is a way how we can get it. So first of all, I'll write the general equation of the, like this, let this be my hyperbola. Let this be the point 3, 2. So there is one tangent from this point which touches the hyperbola here. There might be another which just touches it like this. So remember, this is how it is for, this is the question basically. So I'll write this hyperbola in standard form. So I have x square by 9 minus y square by 1 is equals to 1. This is the hyperbola that I have. I want the tangents to this hyperbola which pass through 3, 2 basically. Both of those tangents should pass through 3, 2. So I'll first write the general equation. So let y is equals to mx plus under root a square m square minus b square. I'm ignoring the minus, like forget about that minus. Let this be a tangent to this hyperbola, right? So first I'll put in the values of a square and b square. A square is 9, b square is 1. So I'll write the final form now. Y is equals to mx plus a square is 9m square minus 1. This is the tangent to the hyperbola. What I know is, I can for sure say that this is a tangent because it's of a tangent form, right? It is of the form y is equals to mx plus under root a square m square minus b square. So it is a tangent to the curve. Now what you know is, it can be either this tangent or this tangent. Doesn't matter. What I know is the tangent is passing through 3, 2. So 3, 2 has to satisfy this. So I can put 3, 2 here. What I'll get is 2 is equals to 3m plus under root 9m square minus 1. Right. So simplifying this, 2 minus 3m whole square is equals to 9m square minus 1. So what you have is 4 minus 12m plus 9m square is equals to 9m square minus 1. So you have 5 is equals to 12m, m is equals to 5 by 12. Let's verify the answer. So this is one of the tangents. Now this question will actually teach you one more thing, which is nowhere related to geometry, but mathematics in general. Why was I able to cancel the 9m square? How did I cancel these? So remember, if I have some 2 plus 3 is equals to 5 plus, or if I have, in fact, let me write it like this. If I have some x plus 3 is equals to y plus 3 is equal to x plus 3, I can cancel the 3's because I know these 3's are finite, right? But you can also have a case. So as you know, if you have a straight line which is parallel to y-axis, then its m is tan 90 tan 90, right, which is infinity. If you have such a case here, if your m is infinity, then I can't cancel these, right? Then I can't cancel these. I'm able to cancel these because I know for a fact that first I'm taking a finite case, but it might also happen that the straight line is parallel to y-axis and then you'll have infinity. So infinities you can't cancel because infinity is indeterminate. Like you cannot have infinity plus 1 equal to infinity plus 2. You cannot cancel the infinities and say 1 equal to 2. That's not valid. You cannot even touch infinities because you don't know what they are. So I'm able to cancel because I'm considering m to be finite. If you consider m to be finite, then this is the case. But what if your m is not finite? That is also possible, right? So if your m is not finite, then you can also have this x is equals to, if your m is not finite, then the straight line has a form x is equals to constant, x is equals to some constant, right? And in my previous equation, I could have that possibility, right? I could have m equal to infinity and that would still satisfy that equation. So x equal to k is also a tangent to this curve, and x coordinate is what the x coordinate that I have is 3. So x equal to 3 is also a possible tangent to this curve, right? And you can actually verify that yourself when you put in here. So something that is more general to mathematics, you can cancel terms only when you know that they are not equal to infinity. If it's possible they are equal to infinity, you have to account for that solution also. You can't neglect it. So let's discuss this problem, second last problem for the day. If it is possible to draw a tangent to this hyperbola of having slope 2, then find the range of its eccentricity. Slightly more involved problem. So we'll first write the general equation to a tangent, which is y is equals to mx plus or minus under root a square m square minus b square. So what do you mean by if it is possible to draw a tangent? So first what we know is the tangent has to have a slope 2. So m has to be 2. So you have a 4a square minus b square. When do I say it is not possible to draw a tangent to this curve? That is when the quantity under the root becomes negative. Until then, everything else is fine. Like if it is not negative, you will always have a tangent. This will always be a tangent to the curve. The only case where it will not be a tangent to the curve is when this quantity becomes negative. Then this under root negative thing will not be defined at all. So it is possible to have a slope 2 only if your 4a square minus b square is greater than 0, or for that matter equal to 0. Right? It has to be greater than or equal to 0. So what I have is, from this 4a square should be greater than or equal to b square. So what you know is eccentricity for a hyperbola is under root 1 minus b square by a square, right? For this hyperbola, the eccentricity is under root 1 minus b square by a square. So as we already know, I'll get b square by a square from this. So b square by a square should be less than or equal to 4. Right? Oh, this is plus, right? It's not minus for a hyperbola, it's plus for a hyperbola, right? For an ellipse, it's minus. So what you have to know is, first of all, your eccentricity has to be greater than 1. It cannot be 1, because if it is 1, then it becomes a parabola. It will not be a hyperbola at all. And then it can go on up to infinity. But here in this case, it will not go on up to infinity because there is a restriction, which is your b square by a square should be less than 4. If your b square by a square has to be less than 4, then 1 plus b square by a square will be less than or equal to 5. And root of 1 minus b square by a square will be less than or equal to root 5. This is your eccentricity, right? So eccentricity has an upper limit of root 5 in this case, and it can be equal to root 5 obviously. That's why this is what I have. It cannot be 1 because if it's 1, it's a parabola. It has to be greater than 1 because this curve has to be an ellipse, and then it has to be a hyperbola, and then its upper limit is fixed, which is root 5. So this is how you do this problem. Let's move on to the last problem of the day, which is you have to find the equations of the common tangents to these two hyperbolas. X square by a square minus y square by b square is equal to 1, and this hyperbola. So for that, what I'll do is I'll first assume a tangent which is I'll first assume a straight line which is a tangent to this, right? So let that be y is equals to mx plus or minus under root a square m square minus b square, right? Now what you want is this thing, this tangent, whatever this tangent is, it should also be a tangent to this curve, right? So simply what I'll do is I'll replace this y and I'll put it here, or and then we can do the same thing. So we can form a quadratic in x and equate its coefficient, equate its determinant to 0. So like what first I'll do is I'll have mx. So take a plus case and solve it first, take a minus case and solve it next, right? Because then you'll get two solutions. So I'm writing plus or minus here for that matter. You'll have to solve it twice. So once again, I'm not getting into the depth of mathematics of this because I have less space to write, and doing lengthy problems I end up missing some data and then the answer goes wrong. So I'll just explain you the procedure and write the answer for you. So from this equation, you can find out, first take x plus separately as a case and minus separately as a case, two cases. Get the coefficient of x square, x and constant for each of the two cases. Equate their determinants to 0. Discriminants to 0. Because why? Because this is a tangent to this curve, right? So it has to have a repeated root, right? It has to touch the curve only at one point. So once you do that, the condition that you'll get is this. A square m square minus b square is equals to a square minus b square m square. So then what you'll get is, get the coefficients of m square, which is a square plus b square, and then you'll also have an a square plus b square that side. So your m has to be plus or minus 1. This is what you'll get once you do what I told. In fact, I would also like to give you a simpler method to do this problem, so that you have to avoid solving that quadratic because it gets lengthy obviously with a lot of variables. So for the first curve, the tangent is y is equals to mx plus or minus under root a square m square minus b square. For the second curve, the tangent to this curve is of this form: y is equals to mx plus or minus, instead of an a square, you'll now have a b square. In fact, you'll have a minus b square m square minus of minus a square, which obviously doesn't matter. These minus signs doesn't matter. But why do I have these minus sign? Because I can take a negative common from here, and what I'll have is x. So basically, this tangent can also be written in this form, right? X square by b square minus y square by a square is equals to minus 1. So that's why instead of the coefficient of m square that you're taking a minus b square, because there's a minus 1 here, and obviously we have a minus. So this is a form that you have to remember, right? I'm not deriving this form right now. It's a very simple process. What you'll have to do is let y is equals to mx plus c be a tangent to this curve. Put mx plus c in this curve and get the value of c by equating the discriminant of the quadratic in x to be 0, because you want a repeated root. That is a standard procedure that we've been doing in all this in this section all this while. Remember that you want the common tangents to these two curves. That means these two lines have to be the same. So the only way these lines are differ by these constants. So what you'll do is equate these constants. You'll equate under root a square m square minus b square is equals to under root b square m square minus a square, which will actually give you the same condition, m square into a square plus b square is equals to a square plus b square. This was the shortcut for doing this problem, right? So it will give you the same answer. I hope you have understood the concept of the tangent drawn to a hyperbola. So with this we complete this topic. Next time we'll come up with a different session with an even more interesting topic in physics. So I hope you liked it. Until then, see you.